Okay, so here I'm going to be discussing about the physiological variations that occur within the cardiac cycle. Okay, so there are three main types, and I'll be discussing them one by one. So we'll start with the increased pressure preload. So what could be an increased preload? Well, preload is anything that occurs before it happens. That's why it says pre. So preload could be an increase in blood volume, like when you drink a lot of water. That can increase the blood volume. What else? Increased venous return will be a secondary effect out of that, and that's why we see that increase in volume. Okay? So, what does an increase in volume mean? Well, increase in volume, as we see here on the left axis, we see that there's a well, we gotta know what this is first. Sorry. Well, we know that the purple one is our normal one. From A to C, we discussed that and we talked that that is the end diastolic volume. Okay? So if you increase the volume, you see that C prime goes towards C. So in other words, end diastolic volume, the end diastolic volume will increase. This end diastolic volume, when it increases, we see that as the ventricular filling of the heart. So what happens when the ventricles fill with heart? Start to fill with blood. Well, there's going to be an increase in the stretch of it. This increase in the stretch will increase the length. That makes sense. And this increase in length will increase the tension, and that is represented in the Frank-Starling graph. You gotta understand that graph in order to know our mechanism, in order to know what that represents. But to make it a review, the Frank-Starling mechanism just represents that as the end diastolic volume increases or the length increases, the optimal length can be reached where the myosin and the actin meet, and that will represent the highest tension that can be obtained. Okay, simple as that. So the greater force of a contraction, so this change, because there's more volume and there's greater tension, we see that D to E will be greater than the normal D to E that represents in the purple cycle. Okay, so that greater force of contraction will project blood more efficiently. Okay, if the end diastolic volume increases, so just to recap, when we see that the end diastolic volume increases, that means that the stroke volume, as can be seen here, will be greater than normal. Why? Because the stroke volume, like I said before, is the difference between the end diastolic volume minus the end systolic volume. The end systolic volume remains the same, and that can be seen in on point A. Remains the same. C, we observe that it changed from C prime to C. Okay, so once you have an increase in end diastolic volume, that difference is greater. Okay, and when the difference is greater, stroke volume is increased.